Good evening. And this evening I'll be presenting on memory cache technique, another computer architecture. So let me ask, what is memory cache? So memory cache is a small, ultra-fast memory storage that stores frequently used data. And the analogy is like a quick access drawer in a desk or cache versus a big filing cabinet or main memory. So the term analogy is a comparison between two things that are similar in some way, used to explain a complex idea by relating it to something familiar. Purpose: the purpose is to reduce time to fetch data from slower main memory or RAM or storage. How cache works: so step 1, the central processing unit or the CPU requests data. Then the step 2, cache checks if the data is present or available. And the step 3, if the data the cache requested is not available, it then fetches from the RAM or storage and stores a copy in a cache. So the visual flowchart of the data is from the CPU to the cache, and from the cache to the RAM and into the storage. So you now have the types of cache. So you have 4 here, maybe there'll be more, but we have 4 here, which is the level 1, level 2, level 3, and then the browser. So the level 1 cache is the fastest and the smallest inside the CPU. The level 2 cache is slower than the level 1 cache and it is larger. So the level 3 cache is shared among CPU cores, slower but bigger. And about the browser or the web cache, it stores website data for faster reloads. Why is cache important? So cache is said to be important because of its speed and efficiency. So for the speed, it is 100 times faster than the RAM, and the efficiency, it reduces the CPU idle time. So for example, the real world example here is without a cache, loading every web page is from the scratch, but with cache there can be an instant reload of visited sites. We come to the cache hit versus the cache miss. So for the hit, data found in cache is very fast. For the miss, data not in cache is slower, whereby it is fetched from the RAM or disk. And the goal is to maximize hits and minimize misses. So cache limitations, we have cost, size, and complexity. So when it comes to the size, cache is small in size, which can be range from kilobyte to megabyte. And when it comes to the cost, it is a faster memory but more expensive. Complexity, managing the cache consistency or multi-core systems. So this comes to the end of our presentation. Thank you.